Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to move on to the next exercise of trigonometric functions from class 11th. Yes, we are discussing class 11th chapter 3 trigonometric functions, and today we will be talking about exercise 3.4, which is based on solving trigonometric equations. Trigonometric equations wherein we actually find the values, the principal values and the general solution of simple equations based on trigonometric functions. Sin x equals something, cos x equals something, tan x equals to something. You are supposed to find the values of x, and the principal values are asked, and sometimes the general values are also asked in such questions. Now this is one of those topics which is a favorite for the JEE people as well. If you are preparing for any competitive exam in general, you will be asked questions based on this topic. What about NCERT? If you are preparing for the school examination, this is once again a very important topic from that perspective as well. And in general, when you talk about, let us say, physics and chemistry applications of trigonometry, you will find that you are sometimes asked to find some unknown angles wherein you will require concepts learnt over here in this chapter, right? So once you have covered this complete chapter, what we'll do here is we'll discuss all the questions asked in exercise 3.4 in NCERT. So let's begin with the first question. What does the question say? Take a look at this. Find the principal and general solutions of the following equations. We are supposed to find the principal as well as the general solutions of the following equations. Now principal solutions, you may recall, principal solutions lie in the interval 0, 2 pi. That is 0 to 360 degree, or precisely 0 to 2 pi. That's the range in which principal solutions lie. Principal solutions. That is solutions lying in 0, 2 pi. The values of x which lie in this interval have to be found for principal solutions. And for general solution, we have some results related to general solution. Let me represent those results once again in front of you. If, for example, if you have sin x equals sin theta, sin x equals sin theta, and you are supposed to find x, theta is known. So this gives me x will be equal to n pi plus minus 1 power n theta, where n is any integer. Where n is any integer. Please observe carefully. This is what you get. Sin x equals sin theta implies x equals n pi plus minus 1 power n times theta. N belongs to integer. There is a simple proof of this, but I am not going into the details of the proof. I am just telling you the final result. This is the final result which you should be aware of. You should memorize. Cos x equals cos theta implies, what is x equal to? X will be equal to 2n pi plus minus theta, where n belongs to integer. N can be any integer. Now this is a general solution. All values of x satisfying this equation will come from here, right? And all values of x which satisfy this can be found here. That is something which you should be aware of. Next, one more result related to tan. X equals n pi plus theta. Please observe, this is n pi plus theta. N pi plus theta, where n is any integer. What happens in case of cot, sec and cosec? Cot is simply the reciprocal of tan, so you'll have to convert that equation in terms of tan. In terms of sec, convert it once again in terms of cos, and in terms of, let us say, cosec, first convert in terms of sine, and then you can answer this question very easily, right? Is that all? Yes, that is all from the point of view of concepts. If you are aware of these concepts, you can very easily solve this question. Tan x equals root 3. Now, one more thing would be required is, for finding the principal solutions, what do you have to take care of? For tan x equals root 3, one simple approach is, one simple analytical approach is, analytical approach. What does the analytical approach say? Analytical approach says that you will have to guess, okay, tan x equals to root 3 implies x will be equal to pi by 3. That is one of the angles. But then the other angle, for the other angle, yes, you will have to think further, and which allied angle satisfies this particular condition is something which you have to find. But let me tell you one more approach, okay. What is that approach? Tan x equals root 3, okay. So imagine if there would have been root 3 or minus root 3, I would have thought about a very unique angle in the first quadrant only. That is this pi by 3. This is pi by 3. Tan x equals root 3 at for x equals to pi by 3, right? That's one of the angles. and the other angle can be found in another quadrant. Which other quadrant will we consider over here? Tan x equals root 3 implies tan x, the value of tan x is given to be positive. Now in first quadrant all are positive, in the second sine is positive, in the third tan is positive, and the fourth cos is positive. So yes, the other value would lie in this quadrant, in the third quadrant. Okay, how do we get that value? This value will be obtained directly by adding a pi by 3 over here. This angle will be pi by 3. Use this line, right? So this is pi, and this angle overall would actually be pi plus pi by 3. This angle overall would be pi plus pi by 3, and you can check that over here with me as well, right? I'll explain all concepts logically from there, and then we'll solve the complete question over here analytically. What do we have? Tan x equals root 3, and we know that root 3 is actually tan of pi by 3, implies x equals pi by 3. This is one of the principal solutions, mind you. There will be another principal solution here, and what will that principal solution be? Let's take a look at this. Also, tan of 4 pi, what do we have? 4 pi by 3, tan of. Now where did we get this 4 pi by 3 directly? The NCERT people don't talk about that, right? And I have explained you a logic behind that, right? And you can now guess where do we get that angle from. So remember, tan of 4 pi by 3 can be written as tan of pi plus pi by 3, and tan of pi plus pi by 3 is also equal to, tan of pi plus pi by 3 is also equal to tan of pi by 3. Very interesting, yes. And tan of pi by 3 is further root 3. So therefore another value of x, therefore tan x equals tan 4 pi by 3 implies x equals 4 pi by 3 as well. Now this is one principal solution, this is another principal solution. At max there will be two principal solutions for any simple equation of this kind, right? Okay, so what do we have over here? Therefore principal solutions, when you talk about, first we are finding the principal solutions. X equals pi by 3 and 4 pi by 3. That's the answer in case of principal solutions. What about general solution? General solution is relatively simple. You find any of one of these values, and in this question it is pretty simple. Tan x equals tan pi by 3. Okay, since tan x equals root 3, I know that root 3 is tan pi by 3, therefore I can write it in this form. Once I write it in this form, then I can very easily write the general solution. Therefore general solution will be x equals n pi plus theta, it is n pi plus pi by 3, where n belongs to integer. This is the general solution. Now, a question arises that I could have written this tan 3 equals tan 4 pi by 3 as well. Yes, I could have written this equals tan of 4 pi by 3 as well, and in that case I would have obtained x equals n pi plus 4 pi by 3. Yes, you would have obtained that. The solutions, the actual solutions that you obtained in this and in that will be exactly same. The form may look different, they may look different, but the solutions obtained would be exactly same. Once you start writing the solutions for different integer values, for example, in this case, for n belongs to integer, what are the solutions that you will get? Please note, what are the solutions that you will get? Let's put n equals 0, so pi by 3 is one of the solutions. Let's put n equals 1, so pi plus pi by 3, which is 4 pi by 3 is a solution. N equals 2, this is 2 pi plus pi by 3, which is 7 pi by 3 is a solution. Similarly, 10 pi by 3 is a solution. For n minus 1, for n equals minus 1, what you will get is minus 2 pi by 3 is a solution. Minus 5 pi by 3 for n equals minus 2, this will be minus 5 pi by 3, and so these are the solutions that you obtain over here, right? There are many solutions, general solutions. Since trigonometric functions are periodic functions, yes, they repeat after certain intervals. The values of trigonometric functions repeat after certain intervals, they are periodic functions, right? For sin x and cos x, the values repeat after intervals of 2 pi. Whereas for tan x, the values repeat after interval of pi. So these are periodic functions with different periods, yes. So values repeat after certain intervals, right? So many solutions are obtained for any equation in this manner in case of general solution. Therefore, we have a method of representing all of these in this form, right? What about principal solutions? Principal solutions are found in the interval 0, 2 pi only. Okay, and many a times in competitive exams, what you are asked is, you are given some interval. Let's say the person would give you minus 4 pi to 4 pi. Okay, find number of solutions in this interval. So in that case, you'll have to deal with a combination of principal and general solution concepts, right? So keep those things in mind while attempting questions. That is all for this question over here. Let's talk about this question. Sec x equals 2 and we are asked to find the principal and general solutions of the following equation. Okay, let's try to find the general solutions of this equation. Principal solutions. Sec x equals 2, this gives me cos x equals 1 by 2. Okay, now remember this quadrant. Cos x equals 1 by 2. You will find one angle in the first quadrant where cos x equals 1 by 2. What is that angle? That is pi by 3. Cos pi by 3, the value of cos pi by 3 is 1 by 2, yes. So first I'll find this angle, this is pi by 3. What about the next angle? The next angle in this complete quadrant, what I'll see is, this is all positive, this is sine positive, tan positive, this is cos positive. I need cos positive. So the other angle would be with respect to this. This line is 0, this line is 2 pi, 0, pi, then 2 pi, 3 pi, 4 pi, right? Those are the lines. These are the angles these lines represent. So I'll consider this, right? I'll have to draw this. This is what I need to draw. This angle pi by 3 will be actually equal to 2 pi minus pi by 3, right? This angle over here is 2 pi minus pi by 3, and for 2 pi minus pi by 3, cos of 2 pi minus pi by 3 will also be equal to that same value, half. That is what you can observe over here, right? So keep this in mind, and then cos x equals to half implies cos x equals cos of pi by 3. This gives me x equals pi by 3 in case of principal solution, right? And also we can have, we do have cos of 2 pi minus pi by 3. What do you call that? 2 pi minus pi by 3. That is another angle that you have. Cos of 2 pi minus pi by 3 is equal to cos, what you have is 5 pi by 3, and this is also equal to what? This is also equal to cos of 2 pi minus pi by 3 is equal to cos of pi by 3, which is 1 by 2. This is the value of cos 5 pi by 3, as you can see over here. This is the value of cos 5 pi by 3 again. Therefore, x equals 5 pi by 3 is also a principal solution. Along with this x equal to pi by 3, another value x equal to 5 pi by 3 is also a solution. Keep this in mind, and therefore principal solutions x equals pi by 3, 5 pi by 3. That's the answer in case of principal solutions. What about general solution? The general solution is relatively simple, right? For finding principal solutions, mind you, I've used the ideas of quadrant, right? On the basis of that, it is very simple. Next, when we talk about the general solution, sec x equals 2 implies cos x equals 1 by 2, and this is equal to cos pi by 3. Cos pi by 3 is equal to 1 by 2. And now I can use the idea of cos x equals cos pi by 3. Therefore, x equals 2n pi plus minus pi by 3, where n belongs to integer. This is what I have. This is my general solution of this question. This is general solution for this question over here, right? Is that all? Yes, that is all for this question. Next, let us take a look at this question. Cot x equals minus root 3. Now, how do we go about solving this? If cot x is equal to minus root 3, then I know that what will tan x be equal to? Tan x will be equal to, this gives me tan x is equal to minus 1 over root 3. Now you see the beauty of that method of quadrants. This is what I have been discussing, right? So this line is 0, this line is pi, this line is again 2 pi. This is first quadrant, all sine, tan, cos. This is what you have. In case you need the values of x for tan x equals minus 1 by root 3, what you are supposed to do is think. Think in terms of when is tan x equals 1 by root 3. Find the value in the first quadrant first of all. Find that value in the first quadrant. So we remember that tan x equals 1 by root 3 when x equals pi by 6. That is 30 degree. So this is the angle I am looking at. This is pi by 6. But mind you, I am not interested in 1 by root 3. What I am interested in is minus 1 by root 3. So tan x equals minus 1 by root 3. That is tan x is negative. Tan x is negative in which quadrants? You can observe tan x is negative in this quadrant and tan x is negative in this quadrant. The angles can be obtained very easily using this idea. Okay, this is pi by 6. What you are supposed to do is, you are supposed to take an angle of pi by 6 over here and you are supposed to take an angle of pi by 6 over here. That's all. That's all. Now what will be the measure of this angle as if you measure from this 0? So this angle would actually be pi minus pi by 6. This is pi minus pi by 6, which is 5 pi by 6. This is one of the angles. What about the other angle? If you measure from this 0, this angle would actually be 2 pi minus pi by 6. This is 2 pi minus pi by 6, which is 11 pi by 6. Yes. Those are the two angles that you want, that you require. Is that all? Yes, that's all. So what do we have? Tan x equals minus 1 by root 3 implies that from here, I know from here, from that analysis which you can do in your rough, you know that tan of 5 pi by 6 is equal to tan of pi minus pi by 6, which is equal to minus tan pi by 6. This is the result, right? We know that tan of 5 pi by 6 can be done as tan of pi minus pi by 6 because this is this. And in case of another angles, we have tan of pi minus theta equals minus tan theta. This is minus 1 by root 3. Also, we know that tan of 11 pi by 6 is equal to tan of 2 pi minus pi by 6. I can write 11 pi by 6 as this. I can write 11 pi by 6 as 2 pi minus pi by 6, and this is further equal to minus tan of pi by 6, which is minus 1 by root 3. And using these two, I can guess therefore principal solutions. When we write the principal solutions, what will the principal excuse me, what will the principal solutions look like? Principal solutions would be this and this. 5 pi by 6 and 11 pi by 6. That's the answer in case of principal solutions. Is that simple? Yes, pretty simple. Okay, what about general solution? Let's talk about the general solution next. General solution. Now, general solution again is simple. It's not very difficult. What are we supposed to do for general solutions? We'll have to apply concepts of general solutions once again. Tan x equals minus 1 by root 3. Now, this minus 1 by root 3, from our previous idea, we know that this is equal to tan of 5 pi by 6, right, from this. Okay, therefore, x will be equal to n pi plus 5 pi by 6, where n belongs to integer. This is my general solution for this equation over here. Is that all? Yes, this is all in this question. Let us solve this one next. Cosec x equals minus 2. Now, how do we go about solving this one? Once again, cosec x equals minus 1 by 2 implies that sin x will be equal to minus 1 by 2. Implies sin x will be equal to minus 1 by 2. Now, once you are aware of this, draw a quadrant. Okay. Sin x equals 1 by 2 will be at what angle x? Please observe, we are considering 1 by 2, not minus 1 by 2. First, let's find the angle in the first quadrant. Sin x equals 1 by 2 is pretty simple. X will be equal to pi by 6. Okay, in the first quadrant, this angle will be pi by 6. Now, you started with a 0. This is pi. This is 2 pi after that, right? And this is all sin, tan, cos. The question arises that sin x will be negative in which quadrants? Sin x will be negative in, as you may observe, these two, sin will be positive in this quadrant and in this quadrant. Now, what angle am I looking at? For sin x equals minus half, I am looking at this angle pi by 6 and this angle pi by 6. I am looking at these angles. But then angles are not measured from pi or 2 pi. Angles have to be measured anti-clockwise from this. what is this angle equal to? Please observe, this is pi and you add a pi by 6, this is pi plus pi by 6, which is 7 pi by 6. And you also have this angle starting from 0 to this will be 2 pi minus pi by 6. This is 2 pi minus pi by 6. This is 11 pi by 6. Please observe that. That's the other angle. That's the other angle. 11 pi by 6. As you can observe using these ideas. Simple ideas? Yes. Okay. So we are not worried about the minus sign initially. No, we are not worried about the minus sign initially. We just found this angle pi by 6 first of all. And then we added pi by 6 to pi. We subtracted pi by 6 from 2 pi depending upon the quadrant in which you want to find the values, right? So since sin x is negative in the third and fourth quadrants, we chose those angles. Right. So sin x equals minus half. With this, we know that sine of 7 pi by 6. Now, once we have solved that much in rough, right? So this will be sine of pi plus pi by 6, and by the concepts of aligned angles, sine of pi plus theta is minus sine theta. This is minus 1 by 2. What about the other angle? Also, sine of 11 pi by 6 can be written as sine of 2 pi minus pi by 6. Okay. This is sine of 2 pi minus 6, which is sine of 2 pi minus theta. Sine of 2 pi minus theta is minus sine theta, which is minus 1 by 2. And yes, these give me the principal solutions. Therefore, principal solutions of this question. X equals 7 pi by 6, comma 11 pi by 6. 7 pi by 6, 11 pi by 6. That's the answer for this question in case of principal solutions. What next? Let's try to find the general solution as well. Let's try to find the general solution as well. General solution would be, for general solution, I'll once again use sine. Sine x equals minus 1 by 2, which is equal to sine 7 pi by 6, as you can observe from here. Right? Once you're okay with this, sine x equals sine theta. What will be the value of x? X will be n pi plus minus 1 power n times theta, where n belongs to integer. So therefore, x equals n pi plus minus 1 power n times 7 pi by 6, where n belongs to any integer. This is what you have, right? That's the final answer for this question over here. How do we go about solving this question next? This question is based on trigonometric equations, but actually it is not a direct question. We have to apply some manipulations first and then we can arrive at a solution in this question, right? This is not a direct question as the previous questions that we have seen. So how do we go about solving this one? Cos 4x equals cos 2x. Now, one of the simple approaches of handling this is, take a look. We know that cos x equals cos theta can be solved by writing x equals 2n pi, this is 2n pi plus minus theta, where n belongs to integer, right? This is something that we know. This is something that we know, right? So can we use this idea for solving this question? Yes, we can use this idea. This is cos of one angle equals cos of another angle. So from here I can say that 4x is equal to 2n pi plus minus 2x, right? Let me write x in this way. 4x equals 2n pi plus minus 2x. Right. What after this? We haven't found x for now. We'll have to find x by further calculation and simplification. So for finding x, we'll have to bring this 2x over here. But how do we bring that? This is either a plus 2x or it is a minus 2x. We'll have to consider them separately. So let's go in one direction and another direction. This is using the plus sign and this is using the minus sign. Let's write it as, this implies 4x is equal to 2n pi plus 2x, or 4x is equal to 2n pi minus 2x. This is what you have, right? Once you have this thing clear, Then you can simplify this by bringing this 2x over here. This will become 2x is equal to 2n pi, or x will be equal to n pi. Obviously n belongs to integer in this case, right? Or we can solve this one. What will this be equal to? This will give us, this will come over here. This is 6x is equal to 2n pi, which gives me x equals n pi by 3, where n belongs to integer. This is what it gives me. X equals n pi, where n belongs to integer, or x equals n pi by 3, where n belongs to integer. And yes, this or this is my answer. This or this is my answer. There's one more catch over here. N pi by 3 and n pi, if you take a look at these, what are the values of x that you'll get over here? You'll get pi by 3, 2 pi by 3, pi, 4 pi by 3, 5 pi by 3, 6 pi by 3, which is actually 2 pi, 7 pi by 3, 8 pi by 3, and 9 pi by 3, which is actually 3 pi. What are you getting over here? Pi, 2 pi, 3 pi. Considering you have some idea about sets, do you observe that this is a superset of this? This here is a superset of this. All the elements present in this are also present in this. This contains extra elements as well, but this is a much bigger set than this. And in case of OR, we see that we have to take the common of these, right? Sorry, not the common, the union of both of these things, right? On taking the union, if you observe carefully, you will note on taking the union, if you observe carefully, leaving the answer at this stage will not be an issue. You can leave the answer at this stage also and go ahead. It's okay. But then on analyzing further, we realize that, okay, this is a superset. And taking the union will actually give me only this set. So the final answer can also be written as x equals n pi by 3. X equals n pi by 3, where n belongs to integer, because this will be included in that. This will be included in that without any worries. But is this all in this question? No, there could have been another approach. Some people would like to follow another kind of approach, and I will also like to discuss that approach, because this approach that I have discussed over here may not be useful in all the questions. Sometimes you will have to use some kind of manipulation of transforming these equations into some simpler versions which can be solved directly. Let's use that and let's see where does that take us. What is that other method of manipulation? Let's take a look at that. I can write cos 4x equals cos 2x in a different way. I can solve this in a different way. It is given that cos 4x is equal to cos 2x. Okay. Why not bring this cos 2x over here? Yes, I can do it. Cos 4x minus cos 2x equals 0. Is that okay? Yes. Once I have written this in this manner, this comes in the form cos c minus cos d. I can apply result of transformation of this difference in terms of product using this idea. Cos c minus cos d is equal to minus 2 sine c plus d by 2 sine c minus d by 2. This is an identity that we know of. If you are aware of this, this gives me further minus 2 sine c plus d by 2, which is 4x plus 2x, 6x by 2. Let's write it as 3x only. Sine of c minus d by 2, 4x minus 2x, which is 2x by 2 is actually x. Okay. This minus 2 will go over there and will become a 0, right, in the denominator. Sin 3x, sin x, the product, if it is equal to 0, the product of two real numbers, if it is 0, then either sin 3x will be 0 or sin x will be 0, right? Let's use that. So either sin 3x equals 0 or sin x equals 0. Either sin 3x equals 0 or sin x equals 0. What about this? Recall. Sin x equals 0 implies x equals n pi, n belongs to integer. This is one result that we are aware of, right? Let's use that result. This gives me 3x equals n pi, or this gives me x equals n pi by 3, n belongs to integer. Here n belongs to integer. This is what I get. Or sin x equals 0 gives me x equals n pi, where n belongs to integer. What is so special about this? We have manipulated and we have solved, but the answer that we have obtained would have been same and are exactly same. Can you observe that? This or this, the answer are exactly same, and that's the complete analysis of this question. Is there anything else which remains? No, nothing else remains in this question over here. Continuing further, let us talk about this question. What does the question say? Take a look. Find the general solution for each of the following questions: cos 3x plus cos x minus cos 2x. How do we approach this? Now, a simple idea when you have a 0 at the right hand side is on the LHS side, on the left hand side, you create some factors, some products of some things, right? A times B, if it is equal to 0, then either A will be 0 or B will be 0, and you can simplify the equation, right? That's what we'll use. On the left hand side, you just have plus and minus and your various terms. Can we combine those terms, right? Can we use ideas of transformation for combining sin C plus sin D, cos C plus cos D, sin C minus sin D, or cos C minus cos D? In that manner, you can use transformation of sum or difference into product. Let's use that idea, right? That's one important thing. That's one important idea for solving trigonometric equations. So cos 3x plus cos x minus cos 2x is equal to 0. This can further be written as, right? I can club these two together and I can use idea of cos C plus cos D, identity of cos C plus cos D. Let me write that identity over here, cos C plus cos D. Yes, there is an identity of cos C plus cos D. What's that? Recall that with me. Cos C plus cos D is 2 cos C plus D by 2, cos C minus D by 2. Yes. These transformation identities would be very useful for solving trigonometric equations as well, right? So this is equal to this. Cos 3x plus cos x would become 2 cos 3x plus x, which is 4x by 2. Cos 3x minus x, which is 2x by 2. Minus cos 2x is already present, equals 0. This is what you get. And observe the way in which it is simplified. It gets simplified. This is cos 2x cos x minus cos 2x equals 0. Once you are through with this, you can take out a cos 2x common and you get a 2 cos x minus 1 equals 0. Okay, this multiplied by this. From here, you can clearly say that cos 2x equals 0, or 2 cos x minus 1 will be 0, right? This product or this product, either this factor will be 0 or that factor will be 0. What happens to cos 2x equals 0? Recall, cos x equals 0 will imply that x will be equal to what? X will be odd multiple of pi by 2. Where n belongs to integers. X will be odd multiple of pi by 2. This is a result that we remember, right? This is something which we remember. On basis of this, I can say that this implies 2x equals odd multiple of pi by 2, where n is any integer. And further, x will be equal to 2n plus 1 pi by 4, where n belongs to integer. This is one part. Or this equals 0. Cos x is equal to 1 by 2. When is cos x equal to 1 by 2? Tell me one value of x for which cos x equals 1 by 2. Guess that. Cos pi by 3 is 1 by 2, right? So this is equal to cos pi by 3. And since cos x equals cos theta, therefore x will be equal to 2n pi plus minus pi by 3. This is what we know from concepts of general solution of trigonometric equations. This. Some people may prefer to use a different variable over here. A different variable over here, yes. Since we have already used n over here, why not use m over here or p over here? 2p pi plus this and this. Is that okay? Will that make any difference? Frankly speaking, that will not make much difference, but this is what you get. So x equals 2n plus 1 pi by 4, n belongs to integer, or x equals 2p pi plus minus pi by 3, where p belongs to integers. That's what we have. Right? Is that all? Yes. This or this is my answer for this question over here. Take a look at the complete solution clearly, and we have used this idea, this idea. Those are the two things that we have used over here. Is that all? Yes. Let's try and solve this question. What do we have over here is sin 2x plus cos x equals 0. Okay. Our target, remember, our target is to take something common, right? What can this simplify into? I see that there is a cos x hidden in sin 2x. How? Sin 2x is actually equal to 2 sin x cos x. Okay, there is a cos x already there. Yeah. In the second term, we can take cos x common. Yes, take it. What remains is 2 sin x plus what remains over here is simply 1. Right? This is what you get. And product of these two factors equals 0 implies that either cos x equals 0 or 2 sin x plus 1 equals 0. What happens to this cos x equals 0? This implies that x will be equal to 2n plus 1 pi by 2, where n belongs to integer. This is the solution, right? For cos x equals 0. What happens in the other case? This gives me sin x equals minus 1 by 2. Okay. Sin x equals minus 1 by 2. So you'll have to find one value of x for which sin x equals minus 1 by 2, and for that I can draw the quadrant. Half. The value half is for pi by 6. Now in the first quadrant sign is positive, in the second quadrant sign is positive, we need sign negative. So we'll have to go to this quadrant or this quadrant, right? Any of these. Let's go to this quadrant. This angle is pi by 6. Okay. This is pi plus. So overall angle would become pi plus pi by 6. This is sine 7 pi by 6, right? Sine 7 pi by 6. This is minus sine pi by 6, which is actually equal to sine pi plus pi by 6. That's what you can observe, right? After doing that analysis at the back of your mind or in the rough, you can easily write this. Otherwise, you will have difficulty in writing this. So keep this in your mind and then write this. This equals sine 7 pi by 6. Okay. So sin x equals sine 7 pi by 6 implies the general solution would be n pi plus minus 1 power n times 7 pi by 6, where n belongs to integer. This or this is my answer, right? This or this is my final answer for this question over here. Sin 2x plus cos x equals 0. Is that all? Yes, that's all in this question. Let us talk about the next question. Sec square 2x is equal to 1 minus tan 2x. Now, how do we solve this one? Sec 2x and tan 2x, the angles are same, 2x and 2x. So let's use interconversion between these two and try to see what will happen. I can write sec square theta as sec square theta is equal to 1 plus tan square theta. Let's use that, right? So this gives me 1 plus tan square 2x is equal to 1 minus tan 2x. This is what I say. The ones get cancelled. Yes, they get cancelled. Let's bring everything on the left hand side. We get tan square 2x plus tan 2x is equal to 0. Once you have reached this stage, can you take out a tan 2x common from both these terms? Yes. and what remains is tan 2x plus 1 equals 0. Tan 2x times tan 2x plus 1 equals 0. Right. What next? Either this factor will be 0 or this factor will be 0. This gives me tan 2x equals 0 or tan 2x plus 1 equals 0. What next? After this, the question is pretty simple. Tan 2x equals 0. What will that imply? That implies that 2x is equal to, if you do not remember this result, recall that sin x equals 0 implies x equals n pi. Tan x equals 0 would imply that sin x equals 0 because tan x is sin x upon cos x. And on the basis of that, I am writing this. Tan of theta equals 0 implies theta equals n pi. Remember that. Therefore, tan 2x equals 0 implies 2x equals n pi, where n belongs to integer. But is this a complete solution? No. Or we have something else. What is that? Tan 2x equals minus 1. Now for me, you are supposed to find one angle for which tan theta is minus 1. One angle theta. So let's draw the quadrants first. For tan x, tan theta equals 1, you have an angle, right? Tan x equals 1, this is pi by 4 and the value is 1 over here. All sine, tan, cos. Tan theta is negative in second quadrant and the fourth quadrant. So I can get an angle over here or I get an angle over here. This is pi, right? This is 0, you started with 0, this is pi. This angle will be pi by 4. So what will this angle be? That is what we require, right? This angle will be pi minus pi by 4. This is actually minus tan pi by 4, which can further be written as tan of pi minus pi by 4. Yes, and this is tan of 3 pi by 4. This is tan of 3 pi by 4. That right. Therefore, tan 2x equals tan 3 pi by 4 implies 2x will be equal to n pi plus 3 pi by 4. Okay. Oh, we've just found 2x. Have we found x? Okay, no. This is not the final solution. We are supposed to find the value of x, right? Let me write this step again. Here also and there also. 2x equals n pi, where n belongs to integer, implies x will be equal to n pi by 2. This is the answer over here, and similarly we'll have to divide by the 2 over here. This gives me x equals n pi by 2 plus 3 pi by 3 pi. Okay, this is a 3 pi by 8, 3 pi by 8, where n belongs to integer. And yes, this or this is my final answer for this question. Take a look at the complete solution of this question. First, we have manipulated, simplified this equation, and then we have obtained the final answer, as you can see over here. Let us solve this question next. What does the question say? Sin x plus sin 3x plus sin 5x equals 0. Okay, there are many terms in addition over here. Let's use concepts of transformation, yes, to convert them in terms of product. How do we do that? Let's rearrange this equation first of all. Rearrange it a bit, yes. Let's take the smallest and the greatest together and then club them together, right? We could have clubbed any two, but then let's club these two together. Sin 5x plus sin x plus sin 3x equals 0 is what we have. Sin 5x plus sin x plus sin 3x equals 0 is what we have. Okay, let's combine these two together. Sin 5x plus sin x. This is sin c plus sin d. Sin c plus sin d is equal to 2 sin c plus d by 2 cos c minus d by 2. Let's use that. C plus d by 2 cos c minus d by 2. That's what we'll have, right? What about the other term? The other term is simply sin 3x. This is equal to 0. What next? 2 sine 3x cos 2x plus sine 3x equals 0. You can take out a sine 3x over here, right? And what you get is 2 cos 2x plus 1 equals 0. Right. What next? Once you're through with this much, you can clearly say that sine 3x will be equal to 0 or 2 cos 2x plus 1 will be 0. That's the other factor. Continue after this. Continuing after this, which gives me sine 3x equals 0. What will that be equal to? That will give me 3x equals n pi, where n belongs to integer, or cos 2x is equal to minus 1 by 2. This is the other equation, right? This will further simplify into x equals n pi by 3, where n belongs to integer. This is one solution. But is that a complete answer? No. We'll have another part also. Cos 2x equals minus half. Find one particular angle for which cos theta equals minus half. Now cos theta equals minus half will be in either second quadrant or the third quadrant. For cos theta equal to half, we know that theta equals pi by 3. So for cos theta is equal to minus half, we can have pi minus pi by 3 or pi plus pi by 3. Idea of quadrants, right? If you have been seeing all other questions of this exercise, you would recall and you'll be able to understand what I'm saying over here in terms of quadrants, right? This is pi by 3 and I'm looking at these two quadrants. This will be pi by 3 or this will be pi by 3. This is pi minus pi by 3 or pi plus pi by 3 are the angles that we require, right? So this is actually minus cos pi by 3, which will be cos of pi minus pi by 3 or cos of pi plus pi by 3. This will be either cos of pi minus pi by 3 or cos of pi plus pi by 3. Okay. Cos of pi minus pi by 3 is cos of 2 pi by 3. This is what we have. Cos 2x is equal to cos of 2 pi by 3. This implies 2x will be equal to 2n pi plus minus 2 pi by 3. Or we can use another variable as well, right? I have discussed that also. Since we have already used n over here, why not use m or let us say p over here, where p is any integer, right? But is that the value of x? No, this is the value of 2x. So let's find x. P pi plus minus pi by 3, where p belongs to integer. Now this or this is the complete solution, complete answer for this question over here. Is that all? Yes, this is all in this question, as you can clearly see. And with this, we come to the conclusion of this exercise of trigonometric functions based on equation solving, equations of trigonometric. This is all for this video. If you have enjoyed watching these solutions with us, please like this video, also share this video with your friends, and also subscribe to the channel of Vyas Edification for latest updates related to all competitive exams as well as NCERT Solutions that we are discussing with you. All the best.